During this course, we've learned about some of the most fundamental and important ideas in investing, like the efficient markets hypothesis and the relationship between risk and return. I don't think you're really ready to invest until you understand these ideas and make up your own mind about where you stand on them. In addition to understanding ideas, you also need to master some skills if you really want to take charge of your own investing. So in the final 3 lectures of the course, I'm going to introduce some essential skills that will help you turn your investing ideas into concrete actions. These skills really complement the ideas we've been learning, and they seriously enhance your ability to evaluate investment choices and make financial plans. In this lecture, we'll learn 3 skills that are essential to making good decisions about investing: comparing returns across different investments, projecting the future value of an investment, and estimating a reasonable price for an investment. All 3 skills involve calculating and comparing numbers that describe your investments. I believe that it's extremely important for you to learn how these calculations and comparisons work. First, you may want to do some of these calculations yourself, or need to do them yourself, in order to make investing decisions. But even if you have somebody else generate these numbers for you, you'll still want to know where these numbers come from and what they mean. That's why in this lecture, we're going to learn to use a few of the most useful tools in investing, the time value of money tools. The time value of money tools I'm going to introduce in this lecture include the timeline, rate of return calculations, compounding, and discounting. These 4 tools work together, first to help you literally picture an investment or investing decision. And then this picture, plus some handy formulas that we'll learn, help you find realistic numbers that you can use in your investing decisions. And best of all, these tools are actually pretty easy to learn. They don't rely on complicated mathematics. In fact, you probably learned much of the math that I'll use in this lecture in grade school. Just imagine how different 5th grade would have been if your teacher would have said, "I'm going to teach you math that could make you rich someday." I'm going to introduce the time value of money tools by asking some simple questions related to the 3 essential investing skills that I introduced a minute ago. Now, the first skill I mentioned was the ability to compare returns across investments. In order to build up this skill, we have to start with a really basic question that every investor wants to know the answer to. What's the return on my investment? Now, to make this concrete, suppose I buy a share of stock for $50 and hold it for a while. One day, I check the price and see that it's gone up to $59. In addition, the stock has also paid me some dividends that I put into a bank account. The total value of the dividends is $3.25, including interest, on the same day that I check the stock price. So the total value of my investment when I check the price is $59 plus $3.25, which gives us $62.25. Now notice that I haven't specified the length of time that I've been holding the share of stock. I'm not concerned yet with the return per year. I just want to know how to calculate the return I've earned so far. When I ask this question, what's my return so far, without really caring that much about how long it's been, I'm asking what the holding period return is on my investment. The holding period return, also simply called the periodic return, is the return that you earn for holding an investment for one period, where the period can be any length of time you want. As we'll see, this is a very important way of calculating and quoting the rate of return on an investment. The first step in calculating the periodic return on my investment is simply to visualize what's going on. So the first time value of money tool I will introduce is the timeline. The timeline is one of those simple but surprisingly powerful tools that can help you organize your thinking when you're faced with complex situations. As its name suggests, the timeline is nothing more than a line that you draw to show the amount and timing of income and expenditures. It can also show you how much something is worth at a point in time. What we do is draw a line, divided up into units of time, years, months, days, whatever time period you want to use. We usually start the timeline at time 0, which we think of as now, or the start of some investment project that we're considering. Time 1 is 1 period from now, time 2 is 2 periods from now, and so on. I usually number the periods below the timeline and write in the amount of money coming in or going out above the timeline. Now let me use the timeline to visualize this stock investment. I'm assuming that I buy the stock at time 0 and check the value of the stock and the dividends at time 1. Again, the length of time between time 0 and time 1 is completely arbitrary for now. So here's what the investment looks like so far. I have the value of 50 at time 0, and the stock price of 59 and the dividend of $3.25 added together at time 1. Note that the total value is the value of the stock plus any dividends. Since I want to be able to think about the general definition of the periodic rate of return, let me redraw this investment using P for the price of the share and D for the total value of the dividend. I'll use subscripts to denote the time when I measure these prices and these other values. So I buy the stock at price P0, and when I check the price of the stock at time 1, the price is P1. Also, the total value of the dividends that have been paid between time 0 and time 1 is D1. Now I'll calculate the periodic return. I take the total value of my investment at the end of the period, which is $62.25, and subtract off what I paid for it, $50. That gives me the dollar value of my periodic return, which is $12.25. In general terms, using the P's and D's, the dollar value of the periodic return is P1 plus D1 minus P0. If I group the P's together, I get P1 minus P0 plus D1 as my dollar return. I like to write it this way because it shows that the periodic return on any investment is the sum of two parts. One part is the change in the price of the investment, which is called the capital gain. The capital gain can be positive or negative, and a negative change in price is often called a capital loss. The second part of the return is the income paid by the investment, which I'm calling a dividend in this case. On the example stock investment, the capital gain is $9, and the dividend is $3.25. So again, the periodic return in terms of money is 9 plus 325, or $12.25. Now, we usually express returns as percents, so I divide the dollar periodic return by my starting price to convert it to a decimal. The answer gives me my return as a percentage of what I paid for the investment. So I take $12.25 divided by 50, which gives 0.245, or 24.5%. So the fraction, which is given by the quantity P1 minus P0 plus D1, that quantity divided by P0, gives me my return between now and time 1. This return is a periodic rate of return, since it's the return over a single period of any arbitrary length. The length of the period could be a year, a month, a decade, literally any length of time you want it to be. And in general, I can measure the return between any 2 points in time, call them t and t plus 1, by using the formula r sub t plus 1 is equal to the quantity p sub t plus 1 minus p sub t plus d sub t plus 1, that quantity, divided by p sub t. Notice that I use the t plus 1 subscript on r, the periodic return, to remind me that that return is earned between time t and t plus 1. So if I plug the numbers from my example into this definition of the periodic return, the calculation looks like this. Rp is equal to the quantity 59 minus 50 plus 325. Take that quantity, divide it by 50, and I get 0.245, or 24.5%, just like I found a minute ago. The advantage of the periodic rate of return is that it's the correct way to measure a return over any length of time. All you need to know are the starting value and the ending value of the investment, including the dividends or income, if any. Now, it may seem like periodic rates of return aren't very useful, but in fact, they're used all the time. You can use periodic rates of return to calculate how much interest you've earned or how much you owe during any period. You may have noticed, for example, when you read your credit card statements, that your credit card company calculates any interest you owe them by multiplying your balance by a periodic rate of return. For most credit cards, the company calculates your average daily balance and then multiplies that by a daily periodic rate to get the daily interest you owe. Then it multiplies this interest by the number of days in the billing cycle to get the total interest that you owe. The drawback of periodic rates is that it's hard to compare periodic rates of return to each other unless the periods are exactly the same length. For example, if I earn a periodic rate of return of 200%, it sounds great if the period is 1 year. But what if the period is, say, 25 years? Well, then it doesn't sound so amazing. We'll come back to this problem of comparing returns in a bit. First, though, I'll ask a simpler question related to my periodic rate of return. Remember that we found that the periodic rate of return was 24.5%. Wow! What will my investment be worth in the future if it keeps up this return? This is something that most investors want to know about their investments, especially when the investments are doing well. Note also that this is the second skill that I mentioned at the start of the lecture. Keep in mind that we want to know the future value of the investment, but we haven't specified the length of each period, so we'll ask the question in terms of periods. Don't worry, we'll bring in days, months, and years in a little bit. For now, though, suppose we ask, what will this stock investment be worth 5 periods from now, assuming that the periodic rate of return is 24.5%? Well, we need to use another time value of money tool to answer that, and this tool is called compounding. Compounding is one of the basic ideas behind the time value of money. You're probably already a little familiar with it if you've ever left some money sitting in a bank account for a while. Compounding describes the fact that if you leave money in an investment, the interest earned during one period will start to earn its own interest in subsequent periods, and so on. To illustrate how compounding works, let's say you put $1 in a bank account today. Then, after one period, the account will be worth 1 plus R dollars, where R is the periodic rate of interest paid by the bank. If you leave the money in the account for another period, then the bank will pay you interest on the total amount in the account at the start of the period. So at the end of the second period, your account contains the money you started the period with, which again is 1 plus R dollars. But the bank also pays you interest on that amount, which is R times the quantity 1 plus R dollars. You can, of course, simplify that to the quantity 1 plus R squared dollars. This works for any number of periods, so that if you put $1 in the bank today and leave it there n periods, then the value of the account at time n, that is, n periods from now, is 1 plus R, that quantity raised to the nth power, dollars. This is easy to visualize on the timeline. Here, the timeline shows that a dollar deposited in a bank at time 0 will keep earning interest and growing for as long as you leave it in the bank. For example, if I put $100 in a bank deposit that earns a periodic return of 5%, then the value of my deposit at the end of period 3 will be 100 times 1.05, that's 1 plus R there, raised to the third power, 3 for the number of periods. When I multiply all that together, I get $115.76. This compounding calculation is called the future value calculation. Future value is the value of an investment or a debt at a future date n periods from now. If I know the periodic rate of return on an investment, I can forecast what its future value is by applying this compounding formula. Formula says that FV of n is equal to PV times the quantity 1 plus RP raised to the n. In this equation, the FV stands for future value at time n, that is, n periods from now. PV stands for present value. Present value, of course, is what something is worth now at time 0. The RP is the periodic rate for whatever compounding period is used to calculate your returns. Notice that we use periodic rates of return whenever we do compounding. Very important to remember that. Let's use the timeline to visualize the future value equation. At time 0, we have some investment worth PV. After n periods, the investment is worth FV, future value, which is equal to PV times 1 plus R quantity raised to the n. Well, now let's return to our original investment. We wanted to know what our investment would be worth after a certain number of periods if it kept up a certain rate of return. We can answer our question by applying the future value formula. Remember that the present value of the stock investment is $62.25, and the periodic rate of return we're assuming is 24.5%. Let's calculate a future value, assuming that the investment keeps up this rate of return for 5 more periods. Then the future value equation becomes FV, our future value, is equal to 62.25 times the quantity 1.245 raised to the 5th power, which gives us $186.20. So this is what the stock investment will be worth after 5 more periods if it maintains that 24.5% return per period. Not too bad. Well, that's all very nice, but most of us like to think of returns in terms of years. So let's ask a question about our stock investment in these terms. We'll use the same numbers as we started with, but now let's say you've held the stock for 3 years. What's your return per year if the stock price went up from $50 to $59 and you earned a total of $3.25 in dividends in 3 years? Well, now we can visualize the stock investment a bit differently than before. Instead of 1 period of unknown length, now we're assuming that you've held the stock for 3 one-year periods. So the picture on the timeline looks like this. But notice that it's the same basic picture as we used to visualize the future value equation. So we can use the future value equation to find our annual rate of return. We know the present value of the investment, which is $50. Remember that on the timeline, now is time 0. So I put the $50 present value at time 0. We also know the future value of the investment, which is $62.25. We also know n, which is 3 for 3 years. The thing we don't know and want to find out is RP. Well, here's the equation. This equation isn't hard to solve. We have 62.25 is equal to 50 times the quantity 1 plus RP, that quantity raised to the 3rd power. And with a little algebra, we find that RP is equal to 0.0758, or 7.85%. This method works for fractions of years too. Suppose, for example, that I bought the stock in our example on October 1st, 2011, and sold it on July 31st, 2013. The length of that period is 1 year and 9 months, or 1.75 years. We can solve for the RP again using the future value formula as before. Only instead of using 3 for the number of periods, I use 1.75 for the number of periods. So now we have 62.25 equals 50 times the quantity 1 plus RP raised to 1.75. When I solve for RP this time, I get that RP is equal to 0.1334, or 13.34%. Now, since we're assuming that the length of the periods are measured in years, that means that this RP is an annual rate. But it's more than an annual rate. It's the average annual rate, or better yet, the compound average annual rate. The idea behind the average annual rate of return is that it's the rate of return that you effectively earn on an investment each year, assuming that this return stays the same and is compounded each year. Many people also call this average annual rate of return an effective annual rate of return, or the compound average rate of return. Before I move on to use the average annual rate of return, let me show you the connection between the periodic rate of return and the average annual rate. The periodic rate and the average annual rate are simply 2 different ways of expressing the same information about a return. If the periodic rate and the average annual rate are really just different ways of looking at the same thing, then you should be able to go back and forth between them. To see that this is indeed true, let's take yet another look at the future value equation. All I'm going to do is write the same future value equation in 2 ways. First, Let's pretend that the length of the periods in the future value equation is 1 year. That means that the periodic rate of return in the future value equation is an average annual rate. And in fact, let's call it R sub AAR. So we can write our future value equation as FV equals PV times 1 plus R sub AAR raised to the n. This means that this is the future value equation for an n-year-long investment. Now, if we take that future value equation and divide both sides by PV, the present value, we get FV over PV equals 1 plus R sub AAR raised to the n. So what, you ask? Well, now let's write the same future value equation in a second way. This time, we'll assume that the period length is just 1 period. But this 1 period is n years long, so it covers the same amount of time as our previous future value equation. The future value equation for a 1-period investment is simply FV is equal to PV times 1 plus RP, where RP is the periodic rate of return for this 1 period. When we divide both sides by PV this time, we get FV over PV equals 1 plus RP. Now, since the future value and the present value are the same in both equations, this means that I can set the right-hand sides of each equation equal to each other, so that 1 plus RP equals 1 plus R sub AAR raised to the n. This shows you how to convert back and forth between periodic rates of return and the equivalent average annual rates of return. All you need to remember is that in this equation, n is the length of the period measured in years. In other words, if RP is the periodic rate for a month, then n equals 1/12, since 1 month is 1/12 of 1 year. And if RP is the periodic rate for 1 day, or a daily rate, then n equals 1 over 365. For example, we saw that the average annual rate of return on our stock was 7.58%. What kind of return would that be on a daily basis? Well, we can use the formula I just showed you. The R sub AAR, the average annual rate of return, is 0.0758, and n equals 1 over 365. When we put these numbers into the formula and solve, we get 1 plus RP is equal to 1.0758 raised to the 1 over 365 power, which gives us RP is equal to 0.0002 rounded to the nearest 10,000th. I wanted to show you this formula because it's extremely important for being able to compare rates of return between different investments. Although some investments will tell you their average annual rate of return, mutual funds, for example, will do that, many times you can't find that information directly and you'll have to calculate it yourself. Here's an example that shows you what I mean. Suppose you and a friend are comparing rates of return on your investments. You say that you made a 15% return over 2 years, and your friend brags that he earned 23% over 3 years. Well, who did better? Well, these are two periodic rates where the periods are of different lengths, so you can't tell just by comparing returns. And don't just divide the return by the number of years. That's a totally incorrect way of finding an average annual return, and it can lead to big mistakes. You have to use the formula I just showed you to convert the periodic returns to average annual returns, and then compare the average annual returns to each other. That's the only reliable way to compare returns on different investments. So, let's settle your argument over who's a better investor. For your investment, RP equals 15%, and n equals 2. So the equation is 1.15, that's 1 plus RP, equals 1 plus R sub AAR raised to the second power, which means that your average annual return is 0.0724, or 7.24%. For your friend, his equation is 1.23 equals 1 plus RAAR raised to the third, which means that his average annual rate of return is 0.0714, or 7.14%. So you did just a teeny bit better. Okay, so far we've used this example of a stock investment to learn several time value of money tools. Now I'll shift gears to a different example to introduce the final time value of money tool for this lecture. Suppose someone wants to sell you a bond that promises to pay you $10,000 6 years from today. You know that the average annual rate of return on this bond is 4% per year. How much would you be willing to pay for the bond now? This question stands the compounding question on its head. Instead of trying to project the future value of an investment, we're trying to find what something is worth today. That's the third essential investing skill that I mentioned at the start of this lecture, finding the right price for an investment. Well, to find this price, the first thing I can do is simply draw the payment schedule on the timeline. We can visualize the bond as a single payment of $10,000 at time 6. So I know the future value and the rate of return, but I don't know the present value. Well, I can still use the future value formula, but I'll have to solve it out for the present value this time. That's not too hard, though. I get that PV equals FV over 1 plus R raised to the n. All we do to find the present value of an investment is to divide by the compounded rate of return. We call this operation discounting because it shows that the present value is going to be less than the future value of the investment for any positive rate of return. As an important note, remember that the rate of return is the appropriate periodic rate. We always use periodic rates when compounding and discounting. Discounting is one of the most powerful tools in finance. You may remember from my very first lecture that most financial assets are contracts that promise to give you payments in the future in exchange for lending money today. Discounting gives us a way to find the value of something that's promised to you in the future. In other words, discounting the future payments from an investment is one of the standard ways that we use to find the right price for an investment today. So in finance, we often say that the price of any investment today should be equal to the sum of the present values, the discounted values, of all its future payments. You may remember a statement like this from the lecture on fundamentals-based stock pricing. According to the fundamentals-based view of stock prices, the price of a stock should be equal to the present discounted value of all future dividends. Well, let's return to the bond pricing example. To find its price, we can use the discounting formula. The future value is the bond payment of $10,000. The rate of return is 4%, and the number of annual periods is 6, since the bond pays you 6 years from now. Then the price you'd be willing to pay today is the present value of this $10,000 payment, which is given by PV is equal to 10,000 divided by 1.04 raised to the 6th, which gives us $7,903.15. What if someone wants to sell you a bond that makes 2 different payments on 2 different future dates? Well, you can use the same basic approach. Find the present value of each payment separately and then add the 2 present values together. The sum will give you the total present value of that bond. Suppose, for example, that the bond we just examined makes a second payment of $10,000 in another 6 years after the first payment, or 12 years from now, in other words. How much is this 2-payment bond worth if the average annual rate on the bond is still 4%? Well, we can get out the timeline again and show those payments. There's a payment of $10,000 at time 6, and then a second payment of $10,000 at time 12. We know the present value of the first payment, that's $7,903.15, and the present value of the second payment then is 10,000 divided by 1.04 raised to the 12th, which gives us $6,245.97. Then the sum of these payments is $14,149.12, which is the price you should be willing to pay. This example highlights a very useful property of present values. They're additive. That is, the present value of a set of payments is always equal to the sum of the present values of each payment calculated separately. So if I have an investment that makes 6 payments, its present value is simply the sum of the present values of each individual payment. Well, in this lecture, we've learned just about all the time value of money tools you'll need to take charge of your financial planning and investing. More importantly, we've learned how to combine these tools in ways that give us real investing skills. For example, one of the main things we've learned is the right way to calculate returns and compare returns across investments. That's a key skill because this information about returns isn't presented in a uniform way in the financial markets. Also, we've learned to calculate future values, and we've made a good start on present values as well. In the next lecture, we'll learn how to put these time value of money tools to work to help us make financial planning decisions.